what I want to talk about, like I said, is a very interesting feature of COMOSYS. And the feature is called IntelliClone. And I want to say that this is a totally new way of looking at how we do steel modeling. Now, what you see on the screen, is a very small building actually, but if you notice, it has most of the features of typical buildings. So it's got columns and beams. Obviously, it's got floor beams. It's got horizontal bracing, which is a very, very common feature. It's got vertical braces. It's got girts. It's got purlins. It's got sag rods. It's got staircases. It's got different inclined beams on the floor as well. Basically, it has a lot of features which typical buildings do. So don't look at the fact that it's small. Look at the fact that it's kind of exhaustive in some sense. Now, what I want to start off with is a very, very nice piece of technology which we call the joint browsing the joints. And you already know about what the joints are in COMOSYS, so I'm not going to waste time on that. But let's see what this joint browser, if you go to the IntelliClone menu at the top, and you go to the Browse Joints button over here. If you press that, what you will see is something like this. So first, let me press the All button over here. On the right-hand side, you see a grouping of different types of connections. Okay. And if you just press All at the top, the entire building lights up. This is not what we are interested in. Obviously, we want to filter it. So let's just remove the All, the building disappears. And let me go to floor beams. Now, if you notice, when at the moment I say floor beams, it filters out from the entire building only those connections which involve your floor beams. Right? As you can see on the screen, of course, this is all types of floor beams. All the different types of connections which the floor beams can have. They're filtered out for you on the screen. Now, if I, for example, if I remove this floor beam and I say my beam column connections and my beam column moment resisting connections, then certain other things are filtered out. So these are my beam to column connections. So here's a beam to column connection. Here is another beam to column connection, etc. Similarly, if I were to say I only want to see my splice connections, then only my splice connections are filtered out. If I want to see only the purlins, then only the purlins in the building and where they are is filtered out. If I wanted to see the girts only, then the girt connections are filtered out for me. Now this is very useful if you notice, because this allows me to step by step go through the various parts of the building. I don't have a truss over here, so that's going to be. So what about braces? I've got some vertical brace connections. What about base plates? I've got lots of base plate connections. If base plates only with the moment connection, so I don't have them. And everything else goes into the other category. So this basically sums down the entire building for us. Let me go back to the floor beam because that's interesting. That itself has lots of, on the right-hand side, we have a categorization of all your connections. And on the left-hand side, it's even more interesting because we have a feature which we call kind of a walkthrough, if you know what I mean. It's a walkthrough feature. So I've chosen the floor beams and it says 19, if you see on the right-hand side. It means there are 19 different types of connections as far as floor beams are concerned. 19 different configurations, 19 different places which I need to solve as far as being a modeler. So what are those 19 different cases? If you come to the left-hand side, we have these little arrows, right? And if I press this next arrow over here, it shows me number 1 of 19. So this is number one of 19. Number one of 19. If you remember, there were 19 different cases. And this is the first one. What has it done? It says that there are places, and how many of those are there? There are 12 of these. So the first type of the 19 has 12 incidents where it occurs in the model. What is this 12 incidents? So it is the case in which the main beam is IPE 300, the secondary is an IPE 160, and there are two horizontal braces coming in, which are 60 by 6, and the other one is 60 by 6 as well. And all these cases are the same. That's the most important thing over here. It has found the similar connecting places for me. So this is the first of the 19. The total, there are 19 groups, let's say. And the first group is this group of 12 joints. And we'll get to how we proceed with that. Now, let me press the next arrow. Let me press this arrow. And it says this is the next one. This is the next case in which the main is IPE 300 and a IPE 160 is connecting to it, but there's nothing else. There's no horizontal bracing. And this occurs how many times in the model? It occurs 16 times in the model, this case. The same condition is over here. The same condition is over here and here, here and here, over here. So it would have been quite difficult to find these in the model. All these are basically the same case. In which there's a main IPE 300 and a 160 secondary. And there are 16 cases like that. Let me go on. Here, it has found another case, and it says there are 12 of these in which there's a single channel. This is a channel. It's a channel profile, which comes at an angle of 45 degrees into an IPE 300 profile, right? And it says there are 12 of these situations. What are these? This is this one, this connection, this one over here, this one over here, this one, and so on and so forth. Very, very quickly, it filters everything out for me. Let me go in and press the next one. And this is another case which it has found in the model. So there's a main, there's a secondary, and there are two braces coming in like that. This is a different case which needs to be handled. Similarly, this is a two-sided connection in which there's a main, and there are two beams coming from each side. And this thing repeats itself in the model in how many places? In 12 different places. As I'm sure you've already noticed, this is an extremely powerful way of walking through your model. And now I'm going to show you something even more powerful, which is how we can, let me just go through all of these 19 very quickly. These are different cases. Some of them are different from each other. This is a double-sided case, for example, like that. So, okay, let me just close this and open this again. Once again, very quickly, all we need to do is use this walkthrough, these walkthrough arrows, to quickly go through my various possible scenarios which I have in the building. This could have been a much bigger building. This could have been like 10 times bigger than this. And it would just go through all of them, group them together, and bring them to you. Now, what do we do with this? Obviously, if I were to press the first arrow and I say, okay, we've got 12 instances of this, what do I do? And this is where the technology of IntelliClone comes in. What we do is we go in, we zoom into any one of them. And we try to find a solution, a modeling solution for this. So I'm gonna do that now in front of you. So let me just pull this back a little. I'm gonna take this. I'm gonna rotate it. I'm happy with this rotation. Then I'm going to remember this is a model which has come from the analysis module. So which means that these things are not in their correct positions. I'm going to lower them, and then I'm going to maybe give it an offset of 80 millimeters. So I'm happy with this joint. Now I know it occurs elsewhere in the model as well, and every place needs to be adjusted just the way I just showed you. But I'm not going to worry about those places. I'm just worried about one place, which is what I'm doing right now. And I'm going to think of a solution of how I can model this. So let me think of one solution. I'm going to use the fin plate connection to the main and the secondary. So I create a little fin plate connection over here. And then I'm going to use my corner bolted gusset to create a corner bolted gusset solution like that, and then like that. And I have finished modeling this joint. And I'm happy with it. There's no clash. I can check the clash, of course, but I'm happy with this solution. So what did I do? I modified these. I moved them down. I rotated them, brought them into certain orientations, lowered them 80 millimeters down. Then I selected anything I wanted, any macro I wanted, created a solution which I was okay with. And now the magic starts. What I do is I select this joint. This joint represents everything. This joint, if I double click it, it says there are four elements passing through this joint: the main, the secondary, and the secondary. And so the joint holds the key information to everything. I select this joint and I select any element from each macro. So I could select maybe this plate, this fin plate, and the plate on the other side. So one element from each macro. I could select 2 or 3 elements as well. It wouldn't matter, but even one is enough. I don't need to select the macro symbol itself. So the node and the any one of the macros. And I've made these modifications. Now at this point, if you just zoom in like that, if I go to the clone selected button over here, and if I press that, I have this other place which opens up, and it says I can have this button called proceed, which means go ahead with the cloning. Now, if I do that, if I press the proceed button, just see what happens on the screen. It'll be very interesting. I press the proceed button, and look what happened. Immediately, in all the 12 target areas, or rather 11 targets, because one of them this is the one I sorted out myself. But the others, which I had not touched, their horizontal braces got rotated, lowered 80 millimeters according to the source, and the exact same connections were created in all the target areas. Not just so. What did it do? It basically saved me. It did 11 times the work which I did. I did work for one joint. It replicated that work or cloned that work in 11 other places in the model. That's very interesting. Now, if I were to press the next arrow key, don't forget, this is a new way of modeling. I'm just going to keep pressing the next arrow key and solve the next situation, right? So what is the next situation? The next situation, for example, let me see what it is. It's a simple case with a beam coming in, but I want to make a connection for this. But let's say I want to make a connection like this. I want to use the stiffened end plate, for example, this one and this one. Now, but the client has a special requirement. The client wants these edges to be chamfered, but I can't do that from the macro. Let's say the macro, if I go inside the macro, it doesn't have the capability of chamfering the edges. So what I'll do is I can explode this particular macro. And now the macro is exploded. And now I can, if I turn on the handles, I can select the 4 handles over here. I'm sorry. Like that. And go to the chamfer button. And if I can give them a chamfer of, let's say, 20 millimeters or something like that, right? Now, what does that look like now? That looks like this. Now, this is just for aesthetic reasons, let's say. This is what the client wants, but this is something which was not possible through the macro. So I needed to explode the macro and make these modifications myself. Now, in this case, I will need to do a selection like this, in which I select all because the macro is exploded. Like in the previous case, I just selected one member, and that was enough from each macro. But in this case, I have to select if there's any, I could have another 2 macros over here and they're not exploded. From those, I will just choose any one. But from the exploded macro, I will choose all the created elements. So let me just select them like that, and the node, if you remember. And that's all I need to do. How many other cases are there? There are 16 other places where the same condition exists. I just press my clone the selected to all, and I just press the proceed button. And when I do that, in all the target areas, I have my similar situation created for me. So this is very, very convenient. Let me go on. Let me press the arrow key once again. This is a different one. In which we have a 45-degree inclined beam channel coming in. Let's do a different kind of a connection over here. Let's use the beam-to-beam end plate connection, for example. And we have this end plate connection in which we have some, but you see the bolts are clashing. So let me go inside the macro and do a little modification. Let's see the first side bolts over here. Let's increase this to maybe 60. So open it up a bit and maybe put another few bolts over there. Maybe this is what I want. And now when I come to the other side, I see that it's really gone too far and I'm not happy with that. So once again, what I do is I select the macro, I explode it. And now I select the individual bolts on this side, not on the other side. I haven't chosen the bolts on the other side. And I do a move, say minus 25 millimeters, for example, in the X direction. So I move those bolts. And secondly, I also select the chamfers of this plate. And I also move them 25 millimeters in the X direction. And this is now an exploded macro, like I said. But I've made certain modifications according to my needs. And once again, what do? I just select everything because now it's exploded and the joint. And the rest of the game is extremely simple. Just, I'm happy with this joint. That's all I need to be. I need to be happy with one joint. And everything else will be cloned according to that. I just press clone, I just press proceed, and we have our results on the screen. So this is an extremely powerful way of going through your building. Let's press the next button. This is another case which you can do. Well, let me do a different kind of a setup over here. Let me move in over. Once again, you see that. Let me rotate these. Like that. Let me bring this down. Let me further move it 80 millimeters down so they're at the same level. Now I'm going to use a stiffened end plate connection over here. And this is going to create a problem for me because now I have a clash with the horizontal bracing. So what I'm going to do is I'm going to go to my steel menu and I'm going to do a manual adjust. I'm going to say I want to adjust this one, say 110 or 120 millimeters in the Y direction. So let me say DY 120. Oh, sorry, I needed to move it in the other direction, sorry. So let me do it again. This one needs to go in the minus direction, I'm sorry, not in the plus direction. So DY minus 120. And for the other one, I do from here to in the plus direction this time, DY 120. So I've shifted my horizontal bracing a bit. And now what I can do is I can go to my bolted gusset command over here. And this one and this one. And what I can do is I can go inside the macro and make some changes inside. So one thing I can do is I can make this 55 like that. So this is maybe 50 is better. Something like that. And I can go over there and remove the left stiffener. So, okay, that works. It's not clashing anymore. What I can do is I can go to the other side from this one and do the same thing over there. I can make it 50 and remove the stiffener from that side as well. I think I've managed. Yeah, okay. So I'm happy. I did a lot of things over here. I rotated the horizontal bracings. I moved them down. I shifted them to the left. I shifted them to the right. And I made some macros and connections. Now, what do I do? If you remember, the targets, the other 20 places where the same situation occurs, they have not been adjusted. They're still in their original configuration as they were. So there's a lot of work to be done over there. But what do? I just zoom in. I select the joint. I select one member because they're not exploded. I just select one member from each macro. So there are 3 macros. I just select one, and I zoom out a bit just to let us see what's going to happen over here. And I press my clone button and I say proceed, and just see what happens on the screen. It's going to not just create the connections, but it's going to actually shift the target horizontal braces as well. This is extremely powerful because this really reduces my work almost 20 times. If you notice, if I'm going to finish this building by just pressing the arrow key, make one connection, say clone, then basically by pressing the arrow key 19 times, I have connected maybe hundreds of joints. And by this way, so this is a unique way of modeling your building, a very different way of modeling your building. And this is what this does. In some places, it will double your speed. In some places, it'll maybe increase your speed by 5 to 10 times. And the good thing is that you will be doing exactly what you want to do. Let's do another example, which is even more complicated. Let's forget about the floor beams and let's go to the beam column moment connections, for example. Now, these are difficult to solve. Over here, for example, we have a situation in which there's a column, there's a beam coming from one side, another one coming in from this side, and the vertical brace as well. So let me just go in and do, for example, a haunch connection between the column and the beam. And after doing that, let me put the middle stiffener as well, because I'm going to be needing that stiffener. Then let me go to another stiffen end plate macro over there and connect the column to the beam also by using these existing stiffeners. Right click, and it modifies those. Let me turn this off. It modifies those stiffeners to make a new connection with the beam. Let me go inside the stiffen end plate macro now and do a maybe 3 into 55, add the number of bolts. So yeah, now I have my more bolts on that. Now I'm going to use my bracing connection to connect the column with the brace, but then also use this existing stiffener as a limiting element. So this is a complicated connection which I've just sorted out. One case which I've just sorted out. Now, if you can see, this is the one, and it says that by pressing the arrow one, I got that. It says there are 4 other places in the entire model where a very similar situation exists. But you can see on the screen that the targets are not exactly the same, in the sense that the angle of the vertical brace is the same in these 2, but it's slightly different for this one. And it's up to me, I'll show the settings later, where I can force it to only find the exact same ones or those which fall within a certain angular range. So maybe 5 degrees, 7 degrees, something like that, I can say. And it will group the joints accordingly. In this case, I've left it a bit open because I know they're all macros and they're going to deal with those situations as well. So I've just sorted out one situation. One difficult situation I've solved as a detailer. And then all I'm going to do now is I'm going to go inside I'm gonna see how many joints I have. I've got one joint inside. That's all I need. That's the one I want. And the rest is the plates and bolts, and that's fine. I could even have chosen any one of those. That would have been enough. But I can choose a selection like this as well, of course. And I pressed my clone button, or rather, let me zoom out a bit and then press it, and just press proceed. And when I do that, my connection, that complicated connection which you just saw, is created not only over here, but also at this target with the slightly different angle coming in. And I'm allowing this because I know that the macro will handle that situation. So all my cases are, so let's do another difficult case. Let's do a base plate. And let's do the one which is difficult, which is the one, so let's do this one, where you have a vertical brace coming in as well. So let me go down to my base plates over here. Let's do just a quick base plate connection over there. And I now want to make a connection for the vertical brace. This stiffener is going to be a problem. So I go into my base plate macro and I remove the P2 stiffeners so that this stiffener doesn't exist. Obviously, still the connection is difficult. So I go to my corner bolted gusset and I say I want to connect the column with the brace with using the base plate as a limiting factor. And then it's still clashing, it's inside. So I go into my macro and I increase this length to 100 millimeters, and that should be enough. Yeah, so this is now taken out the thing a bit, and now it's still clashing because this green plate is clashing with this pink plate, as you can see over there. So to sort that out, what I'm going to do is I'm going to go to my edit menu. And so first thing I'm going to do is I'm going to explode this macro because I want to modify this plate around the pink plate. So I'm going to go like that, and I'm going to say macro explode. So this one is exploded. Then I'm going to say edit plate versus plate adjustment. I'm going to say adjust this plate in accordance with this pink plate. And when I do that, if you see, if I were to show you from close, it has actually modified that plate around that plate. It's not a cut because it's also created a chamfer over here. Now what I can do is I can even create if I go back to the steel menu, I can create a little weld around this point. If I want, I can make it double-sided. I can make it, instead of an edge, I can call it front and back. Anyway, this is just, I'm doing some manual modeling over here. Now what I will do is I will select everything like that. I mean, let's open the cuts as well. Yeah, so I'm going to select everything like that. So what do I have? Let me just control. As long as I have one joint, you never select more than one joint. And the rest are basically parts from either the exploded macros or the unexploded macros. And I'm happy. And this is all I need to do. Now, there are 4 other places where this situation occurs. So I just press my clone button and I press my proceed button. And that's all I need to do. Don't worry about these things showing up because they're just part of the filtering process. But it's the targets which are then modified, as you can see on the screen. So this really is a very powerful way of dealing with large buildings. It's a new way of modeling. It's a very different way of modeling. All you need to do is just keep pressing the next button, and it will take you to the next situation. It will find using very complicated algorithms. These are not simple algorithms. It will find the next place where that situation exists, and it will modify the offsets. So for example, if I were to go to my purlins, if I turn this off and turn on my purlins, and if I, let's say, make some, now in this case, the model looks good, but let's say the model was not good. Let's say somebody had made mistakes and only this one is correct and these ones are not correct. This one is okay. So I just go and make one connection, make sure that I have one connection which is right. So I go to my purlin connection, right click. I don't like the direction of the cleat, so I go inside the macro and I reverse the cleat. And now I'm happy And I know that this situation occurs elsewhere in the model. So it occurs in 1, 2, 3, 4, 5, 6 places. I've just sorted one out, and the targets are not even adjusted. They've got all sorts of offset errors in them. But I'm not concerned with that. I'm just going to select this. I'm going to select rather something like this. So make sure I have one joint and the rest is from the macro. And if you see on the screen, what will happen is, if I just zoom in like that, if I press clone and I press proceed, immediately everything else is adjusted according to the source. The offsets are adjusted on the other side as well. And I have my connection exactly the way. So in summary, what I want to say is that this is a tremendous opportunity to reduce your work by half, maybe 70%, maybe 80%, depending on what the situation is. But what is beautiful about this is that this is very different from something we call joint propagation, in which only single cases in which there's one main and one secondary, those kinds of simple cases are sorted out. No, in this case, we have very complicated cases which we can sort out. Things like this case, for example, in which you have multiple elements coming in, and you can move them, you can shift them. This never happens with commands like joint propagate, which you might have seen in other softwares. This is an amazing technology. We call it IntelliClone, and the purpose was to give you an idea about how it works, what the joint browser is. I wanted to introduce the joint browser. I wanted to introduce this walkthrough mechanism, which is extremely powerful. Just press next, next, next. Just keep pressing the next arrow, solve one node, and just clone. It will find all the other places in the model where the similar situation occurs, and it'll just find a way to clone those situations for. It'll even modify the offsets. It'll rotate the beams, the braces or purlins or whatever if necessary, if you allow it. There are settings which control all this. If you go to the IntelliClone menu, you have settings in which you can control over which elements are allowed. You allow the program to change the rotations and the offsets and things like that, what the tolerance for the angles are, and stuff like that. So very powerful. I hope you liked it. I'm going to quickly now go to the chat area and see if there are any questions over there. Not really. So I'm going to take that as a sign that you found it interesting. Once again, I'll repeat that if you found it interesting, please contact us directly or our resellers in different countries, and they will send you more information about COMOSYS. They will show you the way it works, and thank you.